At about 2 a.m. on March 23, 2005, isomerization unit operators began introducing highly flammable liquid hydrocarbons into the raffinate splitter tower. In normal operations, only about 6.5 feet of liquid should be present in the bottom of the tower. Near the base of the tower, there was a level indicator that measured how much liquid was inside and transmitted this information to the control room. However, this indicator was not designed to measure any liquid above the 10-foot mark, and above that point, operators would have no idea how high or how dangerous the level was. A high-level alarm activated and sounded in the control room when the tower overfilled, but a second redundant alarm failed to activate. By 3:30 a.m., the feed was stopped, and the level indicator showed that the liquid had filled the bottom 10 feet of the tower. We now know that this indicator was not providing accurate readings. We calculate that the tower was actually filled above the range of the indicator to a height of about 13 feet. At about 9:50 a.m., operators began circulating the liquid feed and adding more liquid to the already full tower. Even though the liquid was going into the tower, there was no flow out as specified in the startup procedures. The valve that controlled the liquid flow out of the tower was left closed. 10 minutes later, at about 10 a.m., operators lit burners on the furnace to begin heating up the feed, part of the normal process. Unknown to operators, the tower continued to fill rapidly with liquid to more than 20 times the normal level. We now calculate that the level reached 138 feet inside the tower, while the inaccurate level indicator told operators that the liquid was below 10 feet and falling. Around 12:40 p.m., a high-pressure alarm was activated. 2 burners were turned off in the furnace to lower the temperature. The valve specified in the procedures for controlling pressure didn't work, so an operator used a manual chain valve to vent gases to the blowdown drum and into the atmosphere. At about 1 p.m., operators opened the valve to send liquid from the bottom of the tower to storage tanks. This should have improved conditions inside the flooded tower, but the liquid at the bottom of the tower was very hot, and as it exited through the heat exchanger, it suddenly raised the temperature of the feed going into the tower by over 150 degrees. By 1:05 p.m., the liquid entering the tower was beginning to boil and expand, causing the level inside the tower to increase further. At 1:10 p.m., the tower began overflowing liquid into the piping off the top of the tower. Liquid built up in this vertical piping and exerted great pressure on the emergency relief valves 150 feet below. At 1:14 p.m., the 3 emergency valves opened and liquid began flooding the blowdown drum at the other end of the isomerization unit. Some liquid overflowed from the blowdown drum into a process sewer, but the high-level alarm on the blowdown drum didn't go off. The drum filled completely, and bystanders saw a geyser-like eruption from the top of the blowdown stack. The eruption lasted about 1 minute. Liquid fell to the ground, creating a large flammable vapor cloud. This model predicts how far the vapor cloud expanded across the area just 1 minute after the release began from the stack. At 1:20 p.m., the cloud ignited, causing a series of explosions. The CSB believes the vapor cloud was most likely ignited by a diesel pickup truck parked about 25 feet from the blowdown drum. The next computer simulation shows how the blast pressure wave is predicted to have moved after the cloud was ignited. The blast pressure wave is accelerating as it moves through the ISOM unit, causing heavy destruction and igniting more fires. This is the area where 2 trailers were destroyed, fatally injuring 15 contract workers. This videotape, shot by Houston station KHOU, shows the ISOM unit as fires continue to burn after the explosion. You can see the blowdown stack still emitting flames as hydrocarbons are released. Several vehicles were set on fire and burned in the aftermath. Over 50 large chemical storage tanks were damaged. Firefighters struggled to rescue the injured and locate the missing. The Chemical Safety Board's investigation to determine the root causes of the tragedy began the following day.